Hey guys, what's up? What's going on there? In this video, I'm going to be doing something very simple. I'm going to be explaining machine learning for public health and healthcare professionals. Now, one of the things I want you to understand that is that if you're not in the public health field, some of the explanations I'm going to actually make here still applies to you. But essentially, what we want to actually do now is that we want to actually breed a group of machine learning engineers in healthcare and also in other allied fields. So sit back, relax, and actually enjoy all the details of this explanation. Now, in my previous videos, I've actually explained in practicals how some of the code I've been running works, but I think it's actually important for us to have a theoretical understanding of what machine learning is all about, kind of a pathway for somebody who wants to get started with machine learning in a healthcare field or in any other field. Now, before we start, we might actually want to know what is machine learning from the public health perspective. What is machine learning? Now, looking at machine learning from a public health perspective, we have to understand that at its core, machine learning is just all about, think about machine learning about you're trying to empower computers to gain insights from some sort of data that you are passing to it, right? So without being explicitly programmed. Now think about it this way. You get into a vehicle and automatically the vehicle takes you to your destination or takes you to a certain destination or a destination X. Now this is what machine learning is all about, because in machine learning, we are trying to feed the computer with a pattern of data, and in turn, what a computer does is that based on the understanding or based on the training it gets from that data, it now kind of makes decisions from there. So in public health, this is just like you're thinking about it as you're trying to train algorithms, with vast amount of health data, right? So we want to know what those algorithms are, and then when we now train them with these data, what the algorithm does basically is that it tries to now identify some kind of patterns within this data and makes predictions that we can use in informing, critical decisions. Now let's just think about it this way. Now we have an outbreak. There is an outbreak, right? Probably there's an outbreak of a certain disease. Now what machine learning does now is that it predicts. It does what we call forecast disease. It forecasts, disease spread. And when it does this kind of forecasting, now it makes it now easier and clearer for us to have timely interventions. And also another way where machine learning functions, when you look at it from a public health perspective, is in terms of diagnosis support. Okay. Now, when you have trained a certain model or a certain data set with some form of algorithm, let's take, for example, somebody is suffering from kind of a skin manifesting condition. Now what machine learning algorithms does is that you can now use some form of model to now predict some kind of manifestations on the skin. Now let's use a much more clearer example. A patient complains about a particular ailment or a condition. Now, automatically, what machine learning algorithms can do, if it's set up in a proper toolkit, is that it's now going to use information that is gotten from previous data to now make predictions based on what that particular patient is presenting. I don't know if that's clear. So essentially, that is what machine learning is all about in public health, because it tries to now understand some kind of patterns, and it makes it easy for us to get quicker decision support. And again, it helps us to classify risk, more like pinpointing individuals or populations that are at higher risk, for a certain health condition. So there have been several models where we predict the risk of an individual, the tendency of an individual developing a certain condition. So that is what machine learning does, is that when we classify some of these risks, it helps us to now know when we see a pattern of symptoms from a certain patient, we can actually now say that patient X can actually develop so and so condition because of the patterns that this algorithm has learned from previous data. So it's just all about turning complex data into actionable insights for a healthier world. So just think about it as we feed it with data, the computer learns from that data, and it's on its own able to make predictions when you feed it with what? Maybe some kind of test data, and it makes predictions from it. Now we might now want to understand the machine learning landscape. Okay, so we need to actually understand machine learning properly. Now, what do I mean by that? Now we have what we call, why often we might use terms like deep learning, artificial intelligence, machine learning, and all of that, but so many of these terms are just used interchangeably, right? And there are quite some parameters amongst these terms that are interconnected. So let us just think about it like a nested concept. Okay, now what's artificial intelligence? Artificial intelligence is just like it's just system that simulates that intelligent behavior, the ability for a computer to do something that a human can do. So that intent is what we call what, on the broad set, it's what we identify to be what, an artificial intelligence. Now, when we actually look at machine learning, what's machine learning? Now, machine learning now is those algorithms that it's now going to use in learning to do that thing that it wants to do on its own. Now, essentially, what deep learning is now is that deep learning now is those neural networks that helps in identifying those complex patterns. So deep learning is a subset of what? Machine learning, which is a subset of what? Artificial intelligence. Now we're actually going to look at some of the types of machine learning, some of the tools for public health insights, and essentially this is just a pathway for somebody that wants to get started with machine learning. I just want you to understand that this is that particular pathway that you're definitely going to follow. Okay, so there are actually multiple paradigms. Just think about it this way. Machine learning paradigms offer different ways, to extract knowledge from data, and each of them is one that is really suited for specific public health challenges. Okay, so we actually have what we call the supervised learning, which I'm going to explain. I'll definitely write some code in my next videos. I've been doing that already. We've got supervised learning, we've got unsupervised learning, and we've got reinforcement learning. Now I'm going to actually explain what supervised, unsupervised, and reinforcement learning is all about. Remember that we talked about machine learning as, learning from a data set to have the capacity to make predictions. Now basically what supervised learning is all about is that supervised learning, we're trying to learn from labeled data to make predictions. Okay, so now let us think about supervised learning as you're trying to train an algorithm with the patient data, right? So it could be cancer data. We've collected insights from patients on cancer, and some of the outcomes which usually call the ground truth, it could be present or not present. Now basically what this is all about is, just think about it as maybe in university you're doing a cross-sectional study where you're trying to understand, probably you want to get the you collected a data sheet in your cross-sectional study where you're trying to understand probably cancer patients that developed cancer present, not present, and you have all these data written in your CSV sheet or in your machine learning, what kind of data sheet that you might have, you've got all this data there. Now basically what this means is that what I'm trying to explain here now is that when you enter this data into the computer is having an output of yes, no, present, not present, and all of that, which other parameters, what we call the features, when we're definitely going to explain in practicals. Now basically what happens is that this part of machine learning, supervised learning, what it does is that the computer, when you're feeding in that data, it already knows what it is, right? Basically, it knows what it is. That it knows that the output is going to be binary, probably yes, no, female, male, it's going to be present, absent, and all of that. You're trying to predict disease classification, right? So you're trying to classify those tumors in that cancer. Some of those cancer tumors, maybe it could be tumor or not benign, or it could be malignant, non-malignant, or it could be based on other parameters. So what we want to understand from supervised learning here is that everything, the data sets that the computer is learning from is already known. And this is actually a very good area to get started with, where you might be working on models like binary logistic regression, decision tree classifiers, but we're going to talk about that in our subsequent slides, some of the models. Now, when do we talk about unsupervised? When we talk about unsupervised learning, what we are trying to say here now is that it's just all about discovering hidden patterns or structures in the unlabeled data. Now, let's say, for example, you could feed the computer with several data sheets. It could, maybe you feed it with several models, maybe cat, dog, pussycat, probably lion, and all of that. And that's just what you feed it into. Now, what happens here basically is that we don't really know what the outcome is. So the computer or the model is going to actually say, okay, this is a dog, okay, this is a cat, this is a lion, this is this, based on a kind of observation it makes from its own. So we are not the one to say, okay, this is what the outcomes are. So for you to now read the other features of the data to now understand maybe some kind of predictions to make that, okay, this is now going to be out X, or this is going to be Y, or this is going to be absent, this is going to be present. So an example here now is just that we cluster patients into distinct risk groups, based on their health records without prior categories. So what's going to happen now is that using unsupervised learning models, it's going to now learn some kind of hidden patterns among those patients, risk groups based on their records, and they'll now uncover insights for us. So we're actually going to explain this more in our practicals. Now, for reinforcement learning, just think about it as an agent that learns to make decisions by performing actions in an environment and receiving rewards or penalties. So it's just think about it like you're trying to teach a system through trial and error. Sometimes the model makes a mistake and you're definitely going to correct it. No, this is wrong. You feed it back again, it loops out again, it makes another mistake, you correct it. No, this is wrong. And then, okay, this is correct. Now it adjusts. So we're actually going to explain this on our further course. And this is going to really make a lot of sense for somebody that wants to get started with machine learning, because you must not understand the several paradigms, for understanding machine learning. So for reinforcement learning, I'm going to buttress on that to say that just think about it as you're trying to optimize vaccine strategies by simulating different intervention scenarios, right? And trying to learn the most effective approach. So more like whenever it returns which of them that is not effective, you have to now correct it. Okay, that no, this is not effective, and then it learns from that pattern. Now, we just want to have some more insights on supervised learning again. Like we said, it's more of you're trying to predict health outcomes, and already we know what is available in the data. Everything is visible. It knows that the outcome could be present or not present. It could be yes or no, or it could be infected or not infected. And what supervised learning is perhaps probably the widely most used, is one of the most used machine learning models in public health, that it just tries to enable predictions based on historical data or known outcome. So anytime we are using supervised learning, we already know we get it from previous data. Okay, so when we say historical data is based on what has already happened, we feed it into the computer and it's able to now make predictions. Now, in our last video where we did when I did a practical, if you check my channel description below, you'll see that I talked about how to predict the risk of getting infected from Purulai ulcer, using already parameters that was fed into the computer. Now, this approach is one that involves training a model on a data set. It usually involves tabular, machine learning, where input is paired with an output model, and then the model can now learn to map inputs to outputs. Okay, so allowing us to predict outcomes for new and unseen data. And one of the key applications in healthcare here now, just like I said before, is now you're trying to classify you're predicting outcomes, probably presence or absence of a disease, high, medium, low risk. You're trying to do a regression where you're predicting continuous outcomes, probably length of hospital stay, and you're trying to know blood pressure levels. Okay. So everything you need to know here now is that, from identifying disease presence, yes or no, straight to stratifying the patients into risk categories. So supervised learning provides actionable insights for patients' care and public health intervention. Now we're going to actually look at some of the key machine learning models that are used in public health. I talked about, unsupervised and reinforcement, but all those, we're going to talk about them in our next, sessions. Now let's talk about it now, these models, as we have already explained machine learning as where the computer is able to perform action based on insights it has garnered from data. Now, for you to be able to perform these actions based on the insights it has garnered from data, it's quite important for you to know that there is a diversified, or more like there are diverse toolkits, that is going to actually empower public health professionals to tackle the wide array of challenges. And each of these models is unique. It has its unique strengths and ideal applications. So for you to be able to identify those patterns, there are certain models that we use to train that particular machine learning data to now know, okay, when we now want to now test it, how effective can it be able to make what? Predictions. So now when we're going to look at several models, one of them is the logistic regression. And now the logistic regression is just a simple yet powerful statistical model for predicting binary outcomes. So it's more like we want to know, is there disease or no disease? Is it present or not is it absent? So it tries to estimate the probability of an event occurring, and it's one of the ones that is frequently used. Okay. We also have another model that we call the decision tree, okay? Decision tree classifier. So it's more like an intuitive model that makes decisions by asking a series of yes and no questions. It's more like it resembles a flow chart, which is, if this is correct, okay, go here. If it's not correct, go here, and all of that. So we're actually going to make a lot of illustrations in our next videos with respect to this model. Also, we'll have another one we could call the random forest. And what this model does is that it's just like an ensemble method that tries to combine many decision trees to improve accuracy and reduce overfitting. So it's more like making it robust for complex data sets. So we also have what we call the support vector machines. It's a powerful model that finds the optimal hyperplane to support data into different classes. Okay. So what the support vector machines does is that it also tries to find that particular optimal hyperplane, that is going to separate the data into different classes, even in high dimensional spaces. So we also have what we call the KNN, which is the key nearest neighbors. It's more like a non-parametric, instance-based learning algorithm that classifies new data points based on the majority classes of their key nearest neighbor. So there are actually a lot of machine learning models out there. We have TensorFlow, Keras, and all of them, lots of them. But I also have the gradient, that's the gradient boost, and lots of them, which we're going to be talking about in our subsequent sessions. Now, it will be very imperative for us to actually understand how these models are used in real health problems, because whenever we look at machine learning models, they are not just theoretical constructs. It's quite important for you to know that they are actively solving critical public health and healthcare challenges. And some of the areas where we use some of these machine learning models in the field of public health is particularly whenever it comes to infectious disease diagnosis. I would say that early and accurate identification of these infectious diseases, health in rapid treatment and containment, also in neglected tropical diseases detection, Just think about it as there are lots of skin manifesting neglected tropical diseases, and machine learning models are quite very important in that particular aspect. And it helps in automating the detection of neglected tropical diseases, often in resource limited settings. Also, particularly in outbreak prediction, machine learning is also very powerful, helping in forecasting the trajectory of and spread of epidemics, allowing for proactive public health responses. And again, it's also important to understand that machine learning models are quite very imperative in patient risk stratification, just like we talked about risk characterization. When it identifies some kind of patterns, it can be able to predict the risk, future risk, and all of that. So it helps in identifying patients at high risk for adverse health events, enabling personalized preventive care. Now, also, we use machine learning models in surveillance and monitoring. Machine learning is quite very imperative in enhancing real-time monitoring of health trends and early warning systems for public health threats. So a lot of places where machine learning are used, particularly in rural health problems, machine learning is actually a very widely growing field that is quite very important for anybody to embrace. Now, I'm just going to talk about some of the learning. If you want to learn machine learning, if you want to get started with learning machine learning, particularly as a public health professional, one of the things you need to understand is, first of all, it has to go through a structured process, okay? And some of those is, you need to start with the basics of health data. You need to understand data. What is data, statistics, types of data. You need to understand categorical data, and lots of data management at several levels. You need to also understand data quality, ethical considerations in data handling, because data is basically the fuel for machine learning. Because without data, machine learning doesn't really work. One of the things that makes the machine learning applicable is because of the presence of data. Now, another thing there is you need to actually learn some of the fundamental concepts, and some of them are you need to actually grasp supervised learning. You need to familiarize yourself with unsupervised learning and reinforcement learning, and you need to actually focus on the why and how of each of this model. So more like you need to expose yourself to diverse research questions, making sure you understand a very lot of the reasons why we want to choose which model makes sense, and all of that. And now, before then, I'll actually enjoin you to I would enjoin you to understand some of these models. You need to familiarize yourself with key models like logistic regression, decision trees, support vector machines, understanding their strengths and limitations. And some of these are some of the things you can get through statistics. You need to start getting your hands thorough on data analysis. You need to understand how to analyze data in public health, import data from Excel, handle data, visualize them, understand how to analyze data using some parameters like chi-square, logistic regression, binary logistic linear models, and a lot of them. So it's quite very important. It's going to be a very important pathway for you. So tools like SPSS are quite important. Also, at that stage, our programming language is also very important because it's definitely going to make a lot of things very easy for you. Now, again, another thing you need to get data on is applying these models to real world problems. Essentially, when you're learning some of the statistical concepts, it means that you're practicing and you're applying these models to real world public health scenarios. Okay, you're focusing on problem solving and interpreting some of these results. Okay. And again, is that you need to actually start getting your hands dirty with programming, particularly Python. You need to learn some of the basic syntax of Python. You need to, Python is a very good skill because for you to get started with machine learning, you need Python because Python, Jupyter, and all of that is where machine learning code is being deployed. So it means that you need to acquire Python skills because it's a powerful tool that's going to help you to implement and scale your machine learning application. So it's just the language that brings the whole concept of machine learning to life. Now, we're going to actually look at some of the rules of programming, Python, particularly in your implementation tool. Now, many a times, this is something most beginners battle with. For beginners, programming can seem daunting. It's usually challenging to get started with it. But I would let you know that it's crucial for you to understand its place in your machine learning journey. So think about Python. Just don't think of Python not as a barrier, okay, but as an incredibly versatile tool that empowers you to execute and deploy your machine learning ideas. So that's why you need to actually get very hands on it. Make sure you're always practicing it day by day, and focus on the tool, not starting point. So focus on understanding some of the machine learning concepts first. Then programming is now the means for you to now execute it. Okay, so it's more like you're enabling you to apply what you've now learned. Okay, and you have to be intuitive and powerful. Python is beginner-friendly language, with extensive library like Pandas, NumPy, Scikit-learn, Matplotlib, Seaborn, and lots of them that are used for visualization and data cleaning. And some of the things you need to know is that Python is beginner-friendly, just like I said, and with extensive libraries, a lot for data science and machine learning, making complex tasks more manageable. And also another thing there is that you need to bridge theory to practice. Okay, so more like it allows you to transform theoretical knowledge into practical solutions, from data cleaning to model deployment. So you discover that mastering Python alongside machine learning concepts will significantly accelerate your ability to contribute meaningfully to public health. Now, so your impact is going to be about building a healthier future with machine learning. The journey from beginner to expert in machine learning for public health is something that I would say is really achievable and incredibly rewarding. Each step you take equips you with the power to make a tangible difference. So it's learnable step by step. You need to break down the learning process into manageable parts. Every concept you master, make sure you break it down. You need to talk to your colleagues about what you're learning, and there are real world benefits that comes from it. And some of your efforts will contribute to improve diagnostics, more effective interventions, and ultimately better public health outcomes. So from beginner to expert, it's something I enjoy you to embrace curiosity, practice it consistently, and celebrate your progress. So the field is very vast. I will let you know that, and but your potential to grow is limitless. So join the movement. Machine learning in public health isn't about algorithms. It's about saving lives and improving well-being on a global scale. So I want to enjoin you that your contribution is one that really matters. And don't forget that it's more like you start with understanding what data is, start with statistics, and then some slight mathematics is also very important, like vectors and the calculus might be important. Then you might need to understand data analysis, particularly logistic regression, decision trees, classifiers, knowing what they are. Then before you move to programming Python, that's going to give you the ability to now transform what you've learned into real-time insights, and that's definitely going to be a very significant step for you in your machine learning career, and particularly in public health. So even if you're not in public health, I want to enjoy you that these strategies are really key and really going to be very helpful for you. So I want to say a very big thank you for staying within this video, and I'm going to see you in the next video. Do ensure to like, subscribe to this channel, and share. So see you in the next one. Bye bye.